Okay, 5.3, day 1, part 2. I don't want you to write this problem down, but I just want you to kind of see a little bit of a difference in this question than the last two. So we have 5 cosine of x minus the square root of 2 equals 3 cosine of x. What might we want to do first to solve for the cosine of x? Great, we want to combine like terms. So we have like terms with the cosine of x's. So we would want to maybe get that 3 cosine of x over to the left, and what would we do to both sides? Subtract it. Then 5 cosine of x minus 3 cosine of x is 2 cosine of x. So we combined our like terms. Then what do we want to do? Be careful. Subtract or add square root of 2? Add. So you want to undo that add. Yep, add. Then what? Then divide by 2. Good. And then where do we go from here? Then get that answer from the unit circle. So where on the unit circle do we get the cosine of x equaling the square root of 2 at pi over 4 and 7 pi over 4 for that first revolution? All right, the next example I do want you to write down. Sine of x equals the square root of 2. So we already have the trig function solved, so we want to go out and find it on the unit circle. When is the sine of x equaling 2? Never. Why is it never? It doesn't go that high. It's out of its domain restrictions. What is the domain for sines and cosines?
1.
-1 to 1. So not every time will you have a solution in your questions. A lot of times you will, but there'll be some times where they'll throw some little tricks at you, and this is out of its domain. So there's no solution to exist in this question. You can't solve it for x. So no solution. Okay, I would write this one down. Now I'm going to change a little bit. We're going to get rid of that infinitely many revolutions. We're going to focus on just 0 to 2 pi. And we say the tangent of x equals negative square root of 3. My recommendation before you begin your assignment is to go out your unit circle and on a separate piece of paper, solve for the tangent of x for all of the angles. It'll save you some time later on, especially as we move through the chapter. The reason why is your unit circle only has 2 order pairs. It represents your sine and your cosine. How do you find the tangent of something? A tangent of an angle. Sine over cosine. So we don't know quite yet where the tangent of x equals negative square root of 3. So you may want to take that extra moments, maybe 10 minutes it'll take you to get that done. So we want to find out when do we get the tangent, where on the unit circle, we get the tangent equaling negative square root of 3. So remember, the tangent of theta is sine over cosine. So you'd want to look around the unit circle. Where do you think you might get a square root of negative 3? Probably not in your 0, 90s, 180s. Those are your order pairs, 0s and 1s, or negative.
45s.
Maybe your 45s?
No.
Remember your 45s are square root of 2 over 2, square root of 2 over 2. So it's probably your 30s or 60s, right? Which are going to take you a little more time, because you have to probably do some maybe rationalizing. So from the unit circle, use the ordered pair -1/2, square root of 3 over 2. And I'm not going to do this with you because you kind of did this in chapter 4. You would take the sine over the cosine of that ordered pair. And when you're done, you would get negative square root of 3. And where that exists on the unit circle is 2 pi over 3. And 7 pi over 3, I'm missing one here.
No, 5.
What's the other one?
5 pi.
So it'd have to be this quadrant and that quadrant to have a negative tangent.
Can't be 5 pi.
Yeah, 1/2 things.
You could have this be a positive and this be a negative. Okay, here's our last question. This is probably the most challenging question because factoring comes to be important again. We've spent a lot of time on factoring, and we factor again when we work with trig functions. All right, so we want to find out what can x be in this equation. And we're going to focus on just 0 to 2 pi, the first revolution. And our equation looks like this. 2 sine cubed of x plus the sine of x equals 3 sine squared of x. So imagine this question without the sine of x's in it and just the variable x. What would you do to solve this for x?
Subtract x squared, so you can get 0, it's how long?
Subtract, get it into standard form. How many solutions could you have? Like if you think of it as a degree of 3, then you could have up to like 3 solutions back in the traditional variable. Now we can have more because that unit circle has more choices. So we may want to convert it to standard form. So we take this 3 sine squared of x and we push it over to here. What might be the next step for us? Greatest common factor. When you factor, the number one rule to factoring is look to see if there is a GCF. And there is. What is the greatest common factor for these 3 terms? Sine of x. So we're going to divide out a sine of x from all 3 terms. So what we're left with is the sine of x pulled out. Now we have in the parentheses 2 sine squared of x minus 3 sine of x plus 1 equals 0. Now we have to go inside the parentheses here, and we need to factor it. So either you can use u substitution, which I will, or you don't have to use u substitution. Some of you I know chose not to in some of the problems, and that's fine. Just keep it with the trig in it then, and then do your factoring. So it's your choice how comfortable you are. So think of this as like a trinomial. What are the methods to factor a trinomial? There's 2 of them. Chart, when the leading coefficient is 1. Is that true here? Or guess and check, or AC method. And a lot of these are going to be pretty nice, so you may not even need to do AC method. You're just trying to figure out what are the 2 multipliers of the front term and the last term that'll combine to give you this middle term of negative 3 sine of x. So I'm just going to show it with u substitution. So it's like dropping out these sine of x's here, so it's a little easier to see the factoring. So we're going to let u equal the sine of x. So it looks like this. 2u squared minus 3u plus 1 equals 0. Now you can do AC method or guess and check. What are some multipliers of 2u squared? What are some different ways I can split up 2u squared into 2 terms? 2u and 1u. What are the different factors to split up factoring 1? 1 times 1 or negative 1 times negative 1. Those are your only choices. So you could kind of play with it a little bit and put the parentheses in there with 2u and u, and then one, you need to have a positive 1, or negative 1, negative 1. And we want it to combine back together when we FOIL it into negative 3u. Now we have it factored. So now you just replace those u's back with what u represents is a sine of x. Give you some time to catch up there. Now we have three factors. The sine of x in front, which was your GCF. Then your next two parentheses, which was from the trinomial. What do we do next to solve for x?
Make it equal to
Yep, use a zero product property, set each factor equal to 0, and solve for x. So we're going to set this factor equal to 0 and solve for x. We're going to set this factor equal to 0 and solve for x. And then this factor equal to 0 and solve for x. And here's what they look like. And you're going to help me with this next step. So in the red, the GCS, the sine of x equals 0. How do you find out what x can be then? Sine inverse. So we use that fancy unit circle. When does the sine of x equal 0?
I r 0 time.
So x, sine inverse x could be 0, pi, and 2 pi. You agree? Now let's go over to the green one. Can I use the unit circle right now? No. What do I have to do next?
Minus 1.
Continue undoing, right? So we're going to add 1. When does the sine of x equal 1? Use your inverse trig.
Do you want to divide
Pi over 2.
by? You want to divide by 2 though, since there should be a 2?
Where is there 2? Oh, and the purple one? We're not there yet. We're still doing this one. I just put them in that order. So what angle is the sine of x equal 1? Pi over 2, 90 degrees? Okay. And then our last one. Well, let's use black here. 2 sine of x minus 1, what do I have to do there to undo? Add the 1, and then divide by 2. Awesome. Now we use that unit circle again. When does the sine of x equal 1/2?
R 6 and 5
Pi over 6 and 5 pi over 6. So, and that's from 0 to 2 pi. Here's our solutions. Here is your assignment.